if someone who is, I think, had a very, very interesting journey, it's our next speaker, Bre Pettis, who many of you probably know his story. He started as a middle school art teacher in the Seattle area and ended up CEO of MakerBot, which was just merged into Stratasys. But Bre has and developed a vision from sort of his initial working with Artbox and a variety of systems of making 3D printers accessible, really first I think to the maker community and then a much larger community even beyond that. His passion, his enthusiasm, and his own hands-on exploration and experimentation have made MakerBot really a phenomenon and a leading brand in really a new category. 3D printing has been around a long time, but it was sort of limited like mainframes were in industrial settings. But what happens when we take 3D printers and put them on desktops and put them in places where they've never been before? And I think it's unleashing the creativity of a whole new generation of makers. So without further ado, I'd like to introduce and welcome Bre Pettis.
Okay, that works. Good. And there's a clicker. Good. Okay. First of all, I got to give props actually to Dale and to the Make team. When I was a school teacher, I started making videos, and PT called me up and was like, "Can we please put this on our website? You're the only person really making tutorial videos in 2005, 2006." And I was like, "Yeah, great." And at that point, it was a top 50 blog, and it was a huge phenomenon. And I was like, I'm doing this as a second job. Like, they think this is part-time, but I'm putting everything into this because this is where I'm happiest. This is where the intersection of what I love and what I'm good at, or almost good at, connects. And I jumped in and made videos every week. And I learned something from that around iteration. And this is a theme of today's, which is iteration. And people say like fail fast, all this kind of stuff. But there is a really powerful phenomenon where if you just keep trying and you listen, you move forward to the next stage quicker. And so I'm thankful for the jump start from Make, and that sort of launched my trajectory. At MakerBot, we make this thing called the MakerBot Replicator 2, and it's a 3D printer. And it allows people to iterate straight up. Like, it used to take maybe if you were quick, you could send a project out. It would take 2 weeks, and you could get it. You'd get it back. You'd have like a 2-week turn at the fastest, maybe more like a month. So you could iterate multiple times a year. When you have a MakerBot on your desk, you can iterate multiple times a day. So it just changes the whole pace. And the material is affordable, so if you don't like it, you don't have to show your boss. You can just throw it away and do it again. We're just about to announce a video where we work with Lockheed Martin, and they used a MakerBot on the next generation Space Hubble telescope. And they were able to they basically needed to do work on the telescope that was in a cryo chamber being freeze tested, which I'm such a geek, it's so cool. Cool. And they couldn't work on it because it was frozen, and like literally. And so they made a copy of the part that they knew they were going to have to fix. And they practiced the fixing thing for like a month. And then when it came out of the cryo chamber, they were all set and actually did the fix in just a little bit. So it's one of those things where when we started, we were like, we can make plastic stuff. And we were like, okay, that's interesting. But now we're actually, NASA, JPL, Lockheed Martin are using these for like next generation space flight, which just makes the space really, really happy. And then ordinary people like you and me, get them and make the world a better place by making the things we want. But I'm actually here to talk about the digitizer, because this is the next thing that we're about to launch. And this was, I would say about a year and a half ago, I looked at all the 3D scanners out there in the world because I wanted one. And they all mostly sort of worked, but none of them were easy. And so we ended up I put together a little Cracker Jack team inside MakerBot, a little kind of special ops team that was like, let's see if we can make a scanner and see if we can get something to work. And we built this out of laser cut parts and MakerBotted parts, and we originally thought, well, maybe this will just work and we'll make it kind of old school, kind of cupcake style. We'll just release it as a kit and people can put it together. And then it worked well enough that we were like, no, this deserves to go from a project to a product. So about a little over a year ago, in July of last year, we were right here at Inside MakerBot where we made this. And we really wanted to make it so that people could, it's sort of the inverse of a MakerBot. Instead of taking a digital design and making a physical object, it takes a physical object and makes it a digital design. And what we found is it allowed people to jumpstart into the design process. Whether you were an engineer who wanted to, model, maybe you design water bottles. You can scan a water bottle and start with something, and that gets you moving faster in your design process. And for the rest of us who maybe don't use CAD, it's a way for us to jump in and get create a model in 12 minutes, and then we can go poke at to make our model. We went through a couple different designs. We have some design parameters at MakerBot where we want it to be, where at this point it's black and red, because there's two good designs in the world. There's black and red and then everything else. So, and then we have this sort of rule where it's either 90 degrees or 45 degrees. And that's just, we try and adhere to that rule whenever we can. And we use MakerBots, and this I think is actually a nylon version of it when we start doing concepting and getting it all set up. And then once we're building it, we have modifications to make. We use MakerBots to actually modify. We're sort of eating our own dog food here. And then we like to be playful with it, so we make notes. But you get the idea. Like you can use this, and it just makes design accessible. My daughter is just getting into Play-Doh, and I can't wait till we're just in the final stages of alpha, about to release the software. We should be shipping these in the first week of October. And it's going to be fun to be like, okay, we're going to make something, and then I'm going to scan her Play-Doh puppy or whatever it is she makes, and go into production. So she'll be manufacturing age 2, which what if we'd all become designers and had that sort of jump start? And just the knowledge of I want to make something. I'm going to use my dad's MakerBot and actually go into production, maybe sell it to my friends. And then once you've scanned it, you can actually modify it. And then once you've got something special, you can share it. So we actually started Thingiverse before we started MakerBot because we needed a place to share our digital designs, and because we were telling people, someday you're going to be able to share things the same way you share music and books and movies. And we made it, and mostly it was us uploading uploading stuff at the beginning, but now there's nearly 200 things uploaded every day that you can make today that you couldn't make yesterday because of the power of sharing. One of the things when we started putting this together is we wanted it to be fast and easy. And that's, when you look, you're going to look, we've already seen 4 different 3D scanners come out that sort of look like our scanner since we announced it. But one of the things, we've actually been spending the last 2 years working on the software. And hardware is one thing, but when you're dealing with geometry and turning your point cloud into a mesh, it's a non-trivial problem that nobody had ever really solved in Fluid. And so we really attacked that. So even though it looks cool and it has lasers, the actual coolest thing about it is that it just works and it's easy. And it makes models for you that are watertight that you can just 3D print right away without having to do a lot of post-processing. If you've done 3D scanning before, you've probably had that stage where you're like, okay, I scanned it, now I'm going to spend 4 hours in AutoCAD tidying it up or mesh slabs fixing it up. And we just cut that. And so you can do stuff. This is, it's funny, the Stanford bunny is this iconic bunny that Stanford scanned 20 years ago. And it was really the first high poly count bunny, or it wasn't the first really versatile poly count model that got out in the world that people could test. And it's one of these kind of iconic 3D models like the Utah Teapot. And I actually spent about 4 years with an eBay search waiting for trying to find a ceramic bunny that they scanned so we could scan it too instead of scanning a scan. And so we actually found. I finally turned up and I was like, buy now, buy now. And cats. And one of the things, we're all in the room talking about hardware and innovation, and the theme of iteration comes up. When you use tools that you're comfortable with, and for a lot of people, great tools, it actually doesn't matter really which tool. You don't want to. It's really the one that you know already is the best tool, and if you talk to CAD people, they'll argue forever about which is the best tool, but it's really the one that you know. Same for EEs and really any type of tool. It's the one that you know. I mean, I did all my video editing in iMovie because I could just crash through that and had a really quick workflow with that. Later on, I went to use Final Cut for like more polished stuff. But when you have tools and you know how to use them, that's really the best tool. And for us, we also, at MakerBot, we're on our 4th generation 3D printer, and we've learned so much. We've set up a factory in Sunset Park. And so we were able to, there's things like on the MakerBot digitizer, you'll notice that there's no screws on the bottom. And that's because we didn't want to flip it over when we were manufacturing, when we were putting it together. And there's little tricks like that that you learn when you have to suffer through turning things over in previous products. And it's interesting. You can really we really got our kickoff because we used laser cutting and prototyping, and we actually used prototyping technology to make products when we started. And then we didn't have to use tooling. I've probably got $1 million in tooling in this product, the MakerBot digitizer, because we're making big pieces of injection molded pieces. And that really only makes sense when you're going to make 10,000, when you can amortize that over a bunch. So, $1 million amortized over 10,000 is, $100. The plastic parts, just the tooling costs $100 for each one to amortize it like that. So there's stuff you have to think about and how you make it, and you have to really, in some ways, you have to get the word out there and build your brand, build your work, and get things kind of going, so that then you can do that now with all these prototyping tools. And then when you're ready, when you have a community, when you have a demand, just be ready to crush over and go big. And software development. My software team is I get to work with some of the smartest people. And if there's anything I could, right today, if I could go back in time 10 years, I would take 100 16-year-olds and just teach and really train them to do software that then 10 years later than I could have. People who can do software really well are rare, so when you find them, be nice to them. And so, it's interesting to go from where we were 5 years ago, where we literally had a project we wanted to exist because we wanted a 3D printer and we couldn't afford one, so we decided to make one. And when it worked, we decided to make it for everybody else. From there, we've been able to really just keep iterating and putting one foot in front of the other. And there probably wasn't a market that could have sustained the product we have now. Back then, we were really excited to be shipping 20 MakerBots a month when we started. And now it's thousands. So sometimes I would say if you're starting up, I imagine a bunch of you are either going to start up hardware companies, or you've started them up, or you're going to invest in them. But part of it is there's a long game. And I just met with an artist, Micah Gansky, and he said, it's just like anything with art, because I was talking to him about his artwork and collectors and stuff. And he said, if you find an artist that's committed to being an artist, and they're making interesting work, if you're a collector, you can buy it, and it will likely gain value because they're just going to keep doing their thing. They're going to just keep going, and they're going to build a brand, and he said, you'll never make any money if you invest in art, but if you like it, you'll at least have nice things on your walls. But that same idea of starting and and really choosing your direction that is interesting and is fertile enough, and just being willing to continue going into that for years is something I really would have never thought that I would have done when I was working for Make, doing a different project every week. But I will say that iteration of having to do a project every week is something that is really part of the core spirit of MakerBot, this ability to just reiterate like crazy, and it's super satisfying when you figure out that something's wrong and you have to fix it. That's what I got for you. Thank you.